liaison between the board and GSPE, and that person, will have like a collecting house, send the information to them, they will send it to us. We're going to be passing information out. Be aware that it's going to take us probably a year to physically move next year, so we got a little bit of time to mess with, but once that happens, then we need to be prepared to be moving on. So, this is all in the works. We think it's a positive thing. We hope the engineers and land surveyors think it's a positive thing. So we'll find out what happens. Thank you.
Thank you, Bill. I don't have anything else. I just wanted to make you folks aware we do take a little break over the summer, so there will not be a July meeting or August meeting. We'll pick it back up in September. And there may be a change in venue. We'll make sure that we keep everybody apprised of the new venue, if there is one. How do you guys like it here? Good? Great. It's good to know. Okay. All right. Fantastic. Okay. Our presentation today. Our speaker is Jonathan Weaver, PE. He is Director of Systems Engineering at Jackson, and he's going to speak to us about extreme weather power plants. Please join me in welcoming Jonathan.
All right, thank you. So just a little bit about me. I have been in the industry. June 10th was 20 years that I've been in the utility industry and at Jackson Electric Membership Corporation. I am there the Director of System Engineering, which means that I'm responsible for the planning and expansion of our distribution system. So that's what I'm going to focus on primarily. But I will touch on some things that I don't do, that I kind of help out that some of the other people do, just so that y'all have a complete picture of what it's like to be in the distribution utility business. I got my PE, I guess, about 10 years ago. The story behind that was my wife let me know that we were pregnant with our firstborn child. I said, okay, and assuming that life would end at her birth, I started studying. I got my PE, and when we got back from the hospital, I got my PE letter saying that I had passed the exam, because I took it just a couple of weeks before she was born. So that's how that worked. But anyway, on to the presentation. So we're going to be talking about planning of our utility grid, and I'm going to start out with some electric utility background, just so that y'all kind of are familiar and know. I'm not going to assume that you know anything, so I'm going to start at square one. So this is square one. We have generators that generate electricity, transmission lines. So the first step is you step the voltage up, and then you transmit the power over high voltage lines. You do that because you can transmit a lot of power over a long distance that way. Then you have substations that bring the voltage back down. Then you have distribution lines that bring the service to the end consumer. So my focus is on the distribution lines, and also I get some input in on the substations, the last substation before it gets there. But I kind of wanted to talk a little bit about the people that I work with. So one is on the generation side, we have Oglethorpe Power, and they own generators throughout the state. They are an EMC that we're a member of as an EMC. So the way EMCs work is the people that are customers also own a share in the company. So we own shares in these companies, and we're also customers of these companies. It helps a lot with things like keeping the business doing the things that the customers want. Next, talk about Georgia transmission. So there's transmission lines all across the state. You kind of see the web. So what I wanted to get the point across here is that first picture I showed you is a gross simplification of what's actually going on. They call it the electric grid for a reason. All of these lines are connected. It's very, very complicated to do the math, to figure out where we need to add new lines. I don't do that. Thank God I'm not in transmission. Distribution is a little bit easier there because it's not networked. And that means that our lines work in singularity, not collectively as a group, the way the transmission system does. And then there's Georgia System Operations. So these are the guys that track the load on a minute by minute, second by second, hour by hour, and they make sure, because electricity is a unique market, generation has to equal consumption all the time. And if it doesn't, the generators will slow to a halt or speed up too fast, and then things start to trip offline and you have mass blackouts. So without these people, it's very important. Then there's 38 EMCs that participate in all of this, 40, I think you're looking at me. It depends on what you count. So 40 for GSOC and GTC. And they're identified by all these red groups. So we're all kind of focused on our little piece of this great big huge rotating machine, right? 60 hertz all the time, the entire North America, except for Texas. Texas kind of stands by itself, but we won't talk about them. They're weird. So here's the deal. The industry is conservative, and it's conservative by design. So we do a lot of redundancy. There's a lot of redundancy. And so standard design is that we want to be able to restore